So, hi, I'm Matthew from Magnavale. I'm going to talk about digital twins in the cold storage market. Firstly, a brief introduction to Magnavale and what we do. So we're the largest independent temperature-controlled warehousing platform in the UK. We provide temperature-controlled warehousing down to -25 degrees for an array of customers, from food manufacturers to retailers from 3 facilities. We are also developing a 100,000 pallet fully automated cold store in Lincolnshire, which will be the most efficient facility in the UK. So why create a digital twin? Historically, there were no digital representations of processes operated at Magnavale. Traditionally, cold storage operations do not maximise the use of IT. The digital twin allows Magnavale to represent as-is and to-be processes, to monitor real-world performance against digital simulations, assist with budgeting, determine customer pricing and profiling, and offer an impartial view of performance. We have developed an array of applications in-house. Firstly, there is the main block of a digital twin. Here we've defined a range of tasks per customer and where completion times have been assigned to each task. We take data from our warehouse management system and run it through the task log to compute required resources. Additionally, we can use forward-looking budget files to plan ahead. Next, we have a power model. We're a large user of energy, so it's important we monitor performance accurately. Again, we use data from the warehouse management system and include external factors such as weather to estimate energy usage. We then use this data to complete a cost to serve model where we can see granular output based on customer or product type, for example. Finally, we have a put away model that is used to generate put away times of the product in the warehouse. This accounts for stored layout, speed travelled, and racking types. Next, we have some example output from the digital twin. This shows actual labour versus the labour requirement modelled by the digital twin. So here we can see there's 2 different facilities. One is operating a fixed shift pattern and the other variable. The digital twin allowed us to see that each approach was roughly in line with the output predicted by the digital twin. The digital twin also used to model equipment required, such as reach trucks, forklifts and PPTs. How we implemented our digital twin. One of the biggest hurdles was resistance from the existing workforce, who initially showed distrust of the approach. So we overcome this resistance by holding regular workshops with operations to explain the benefits of running the digital twin, involved operations in the design of the digital twin, and employed an incremental approach so not to overload users. We also showed benefits from day one. It's also key to share results so people get the output for which they have contributed. Our digital twin is shared with management in our KPI suite, so it's visible across the company. Feedback on the digital twin is also encouraged by enabling management to comment on the output. For next steps, we're working with external parties to provide visualizations of the digital twin data. As Magnavale develops more automated facilities, we see a larger role for digital twins, especially with assistance in designing layout of new facilities and to determine more efficient work practices. We can also look to exchange data externally, sharing data with energy suppliers, haulage providers, and customers to ensure integrity across the supply chain. In light of COVID-19, we could also share stock holdings with government departments so they could work out how much stock holding is in the supply chain. So I hope this has given you a brief insight into digital twins and how we can use them within the cold store. I'm happy to take any questions you might have.